In our last video, we mentioned that we wanted to do a build of either a IC engine or a steam engine, and we got quite a few answers on that. And the one thing that was pointed out to me is very few videos out there on IC engines, and there's tons of them on steam engines. So we decided to do the 6-cycle Oddball, which is a very simple IC engine, and I think we can do it fast enough so it won't get boring. We'll do 1 or 2 parts a week, and you'll have time to digest that. And the plans for it are in this book. I'll give enough information, you probably won't even need the plans, but if you want the plans, they're in this book, and that's the only place I know you can get them. So this is the engine we're going to be building. This is either my second or third version of this. I can't remember how many I built, but I built at least 2, maybe 3. And I've run this engine at every show that I've ever gone to, and I ran it all day long, and it's a very, very good all-day runner. It'll burn about 2 tanks of gas in 8 hours. So it's really a good engine. If you get it running right, it's wonderful. And the thing that's attractive is the flyball governor. You can see it operating, and it attracts a lot of attention. So the first part we're going to make is the legs, or the bottom of the base. We're going to make 2 of these, and I've already cut the material out. I cut a chunk out of this, and I've got them here. They're super glued together, and I got to take a few more finish cuts on them, and then we can make this part. Talking about the top part here. The original engine calls for almost all steel, I believe. I make it out of aluminum to make it lighter. It doesn't really matter. I'll tell you what you can make it out of. It's almost all these parts can be made out of either steel or aluminum. But this is what I selected. This is 3/4 by 1 inch, 2 pieces glued together. And it really doesn't matter a lot if the size is perfect. The thing that really matters in this part is the distance between the 2 slots that hold the main sides of the engine chassis. So this is the real critical dimension here. And I say real critical, it's probably critical within 20 thousandths. So it's not a problem. First operation, I'm going to finish this off. And it says it's 1 inch, but it isn't important, because there's a 1/4 inch between the flywheel and the base of this engine. So if they're a little shy, it won't matter. So I'm just going to finish them down till I get a clean, flat cut. So that finishes it. I'll measure it and see what it is now. It's probably under 1 inch. It's only 10 under, but that's good. So now what I'm going to do is do the ends. First I got to take the burrs off it that I caused. And then I'm going to do the ends and make it to length. It's supposed to be 4.5 inches. 4 3/8 inches. So 4 3/8. I'm just going to square that end. The other end's pretty good. You got to get a long end mill to square it. That's square. You know, there's a little thing here, but we're going to cut a feature in the end, a little curved feature, so that will disappear, and this hole that's in this end will disappear. We're going to put a little bluing on here. So this is, because I squared it, this is a tiny bit short, but that doesn't matter. The width of this makes no difference. The important thing is the 2 slots that you're going to make to hold the size of the chassis, and those have to be the right dimension. So what it shows is the dimension from the center. So I'm going to determine the center here and make a line. Okay, I'm going to set this for the center. Make a line. And then I'm going to flip it over this way and make another line. And they better be both in the same place. If they're not, they haven't got the center. It's always a good way to check that. So now we've got 8, 12, I think it's 13, was it 13, 16? Yeah, 8, 12. So I'm going to take this center mark and subtract 8, 12. One, 3, 24. 1, 3, 24. Okay, and what I'm going to do is make a light line there, and flip it over, and make another light line here. So now what I'm going to do to double check myself is see what this dimension is and see if it matches the print. That's supposed to be 1 inch and 5/8. That's 1/625. Whoop. As close as I can measure it, we're right on. We've got to go down 1/2 inch because the sides are 1/2 inch wide. So we're going to go minus 0.5 equals 824 thousandths. That should be the rough measurement. I'll measure those to make sure they're 1/2 inch wide. They're perfect. So now, roughly, I know that's where it should be. But what I'm going to do is use the DRO on the milling machine, and when I do this dimension, I'm going to do it with the digital reader. So those are 1/2 inch wide and 1/16 inch deep. Now this is probably the only really important dimension on this, is between those 2 points. I'm using a fairly new 1/2 inch end mill to avoid any trouble. What I'm going to do is eyeball the first one. That's as close as I can get it by eye. And then I'll use the digital readout to come over to the second one. Now the depth of this is not that important, around 60 thousandths to 62 thousandths, as long as they're both exactly the same. The first cut, and that's 65 thousandths deep. So I'm going to leave that set at the same point. I'm going to zero this so I know where that is. So now I'm going to move over. It says 1 inch and 5/8 between them, so I got to go another 1/2 inch. So it's a 2 1/8. We're going to crank it over 2 1/8. That's 4 1/100ths of an inch. That doesn't matter. So this should look, if I crank this up a little bit, notice I've zeroed that, so I can come back to 0. And you can see that lines up with my line, so that's like a double check to make sure I did it right. Okay, the last cut's only going to be 2/1000, which should make it pretty accurate. Whoop. And that's it. If we did everything right, if I measure that, it should be 1/624, 1 5/8 is 1/625. Boy, that's pretty close. It's within 1,000. No, actually, well, as close as I can measure it, it's perfect. Well, it's 1 under, 1,000th under. Just gotta take the birds off it so that it'll go in the vise right. Now the next thing I'm going to do is this curve feature here, and that doesn't, you know, there's no dimension there that really matters. It says a 1/2 inch radius, but if it's, you know, 5/8 radius or whatever, it doesn't really matter. As long as you leave a little point there to hold the sides. And how deep it is, I mean, that could be half that thickness, it wouldn't matter. I'm going to put some bluing back on here so I know what I'm doing. So I'm going to make a mark on there about a little over 1/8. I'll leave 150 thousandths on each side. And like I said, I'm going to come down here and leave enough meat to hold the engine in place. So I'm going to use a fly cutter to do that, and I've got to set the fly cutter. And I don't know, I've showed this block before. This is something I made up. This hole is exactly 2 inches from this end. And the same with this hole is 2 inches from that end. And that's the 3/8 and that's the 1/2 inch. So if I put this in the 3/8 hole, and I want a 1/2 inch, if I deduct a 1/2 inch from 2, I get 1 1/2, and that's my 1 1/2 point, and it's held on with magnets. So I just put that up there. That'll give me a 1/2 inch. So I'm just going to feed this by hand at first. Anything can happen here. I'm going to use the power feed to do this, now that I've got it set up. This should be the last cut. And you notice the hole that I had in the end is just barely went away. I was kind of concerned about that, but I won't have to fill that. So turn this back on. Almost to the line there. I'm going to do one more cut. That'll be a cleanup cut, and that'll be it for this feature. Okay, that's it, the last cut. The thing I'm gonna do is cut the relief on the bottom, and that just means nothing. It's just takes the meat off the bottom. It takes a while to do that, but it's so that it will sit flat. If you had left that straight and you put it on a flat surface, it might not sit flat. You want just the ends to hit. They're showing that roughly a 1/2 inch wide, so I'm going to mark that a 1/2. And a 1/4 inch deep. So I'm just putting a mark there for a rough. It doesn't matter really how much you do. But so I got to remove that portion. This is just a feature to give it clearance in the middle, and you're leaving approximately a 1/2 inch here. And it's calling for a 1/4 inch radius, but I'm not going to do that. I've just put a radius tool in my fly cutter. Because I have power feed, I'm going to use that, and that way I won't have to do so much cranking. So I'm going to take off some cuts of, I'll try 20 thousandths first, and see how that goes. Slow it down some because it's a pretty big cutter. This should be the last cut. I set this for 0 and the other, we'll see how close it is. 2 1/100ths, yeah. So the next thing we got to do is make the undercuts for the hole down bolts, and then we have to drill 4 holes here and counterbore them, and that's it. Now I'm just going to mark these for the holes, and they've got them in probably a 1/4 inch from the edge, so I'm going to mark those first. So these are supposed to be 3/4, so that's 1.5 inches wide. It's a little over. So they're 3/4 thick, so I'm going to go up 3/8 and mark it. Both sides, 3/8, 3/8, and then I'm going to set it for a 1/4. Mark them this way. And I'm going to drill those holes from the bottom because it's curved up here. And then later I'm going to flatten that off. I'll show you that afterwards. So these aren't super critical, they're just the hole down bolts, so I'm just going to do them on the drill press. And then I'll do the relief on the other side in the milling machine. It's calling for a 3/16 hole for a hole down. I think that's a little large. I'm going to drill a 1/8 inch pilot hole, and then I'm going to take them out to 5/32. I can always drill them big later. What I did is I put a 5/32 hole there instead of a 3/16. And the reason is I'm going to use a number 5 bolt to put that down with. They probably used a wood screw, and that's why they had such a big hole. But I like the looks of a bolt there. So what I did on this engine is I used a number 5 bolt with a washer under it. So this is 5/16 wide, and it goes in how far? It goes in about 400 thousandths, or 420. So I'm going to put a 5/16 end mill in and just do a little flat there for the bolt. So I did a little math here, and I determined that if I use a 5/16 end mill, I'm 219 from each edge. So I'm going to mark each edge at 219 for a reference. And they went in 420. Now I don't know if I can mark that or not. 420. Now see, I can't get in there, so I'm going to have to do it the other way. Do it this way. Come down 1, 2, 3, 4, 10, 20, right about there. So this is where they'll end up. That just gives me a reference. So they'll all be pretty much the same.
Got it. Perfect.
So I put in a 5/16 end mill, and I'm going to line that up with the edge here somewhat. That's going to be good there. You come in here. I got to get it down so it's just touching. And I'm going to go about maybe 20 thousandths deep. I'm just doing this by eye. Drag it into the line. Now, I'm going to zero this out so I can crank this up and come back to the same depth on the other side. So that's that. And now the only thing we have to do is put the hole down holes. And I'm going to do that from the top side too in the drill press. Okay, what I'm going to do is, these are 3/4 thick. So I'm going to set this at 3/8, which is half, 375. And put a mark on all of them. 3, 4. And then I got to do it this way, and this isn't quite tall enough, so I've got to get a better angle plate. So there's a 1/2 inch wide, so I'm going to come down there, and then I'm going to go 250. 1, 250 is right there. And mark those. Flip it over. Mark the other one. Now I can prick punch them and mark them. So they're calling for a number 10 hole, number 10 drill bit for the hole, and that's a clearance for a 1032 screw. So that seems logical to me. A 1032 cap screw should be nice, plenty strong. Slot drill all these holes, and then drill an 1/8 inch hole through, and follow it up with a number 10 drill. That's the 1/8 hole. I'm going to open those up and go in there with 11/64 and then do the number 10 drill. I'm going to go to the number 10 drill and open them up to size. If you step your drills up slower, the slower you go, the more accurate the hole will be. So this doesn't really have to be exactly on, but I like to keep things pretty well centered. The next thing is to counterbore the hole for the screw head. So now I'm going to do the counterbore for the head, and I happen to have that counterbore. If you didn't have a counterbore, you can use a drill bit. It just doesn't make the bottom of the hole flat. So this is exactly 200 thousandths I got to go for. That's the depth of the head. So I'm going to set that for 200 so I can set this. And I'm going to bring this down. So bring this down to 0. Like that. Now, I like to bottom the tool out in the chuck if you can, because that way you get an accurate measurement. You know it can't be pushed in as you're counterboring. So that's 0. I'm going to set this to 0. You see that? And then what I can do is, now I'll go in 200 thousandths from there. You got to turn the speed way down, very slow. There's the 2 pieces. The glue failed right at the right moment. I think I got them a little warmer when I drilled them. So now all I'm going to do is touch up these holes with the countersink to make them look professional, and then those parts will be done. So there's the 1032 screw. Fits in there nice and flush, and I've got probably a 1/4 inch sticking out here, so that's probably a good length, but that'll work perfectly. So that part is finished, and next week we'll make the side pieces, which is the chassis, and maybe the front plate too, because the side pieces are pretty easily done. I'll rough them out and we'll just show you what. Basically, it's the holes. That's it. The front plate's the only complicated part. So that's the end of part 1. I thank you for watching, and if you liked what you saw, please give me a thumbs up and subscribe to my channel. Thank you very much.